Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied a numerical which was based on Faraday's first law, and now what we are going to do is we are going to solve the third problem which is based on Faraday's first law. So let us see and let us determine what will be the answer for that. So as present on the screen there is a question which is related to a current of 6 ampere is passed through AlCl3 solution, that is aluminum chloride solution, for 15 minutes using platinum electrode. When 0.50 gram of aluminum is produced, what is the molar mass of aluminum? So initially we have did the estimation of weight, then we have did estimation of the time, and now we are going to estimate what would be the molar mass of aluminum. So let us do this equation and this question. But first of all, the thing that we should do is we should extract the data present in the given question. So the first thing that we are getting is 6 ampere of current, which means I is equals to 6 ampere. Then the time, that is 15 minutes, is will provided to us, and the time should be converted into seconds. And now the weight, that is, it is also been given, that is 0.504 gram, and because of which we have to calculate the molar mass of aluminum. So let us see how can we calculate this. We know that the data that has been provided to us is current I is equals to 6 ampere, while that of time is given as 15 minutes, which should be converted into seconds. So for 15 into 60 will give us a number of 900 seconds. And the last, that is W, that is weight or mass of the particular substance that has been deposited during this process, was 0.504 gram of aluminum. So every data is with us, but the one data which is not with us is, yes, the equivalent weight. So we can calculate it by the formula W is equals to Z into I into T divided by 96500. So the first thing that we have to estimate or we have to determine is the value of Z. So therefore we could write it in this way. Therefore Z is equals to W into 96500 divided by I into T. And now in this case the value of W is given to us is 0.504 into 96500 divided by the value of current is given as 6 ampere and the value of time is given as 900 seconds. So by the help of this we could estimate the value of Z as So the equivalent weight of the aluminium in this solution was found to be 9. But with the help of this we could also estimate what would be the molecular weight of the silver. So let me give you an information that the solution that they have provided to us is AlCl3 solution. So when AlCl3 is being dissociated, it gives us Al3 plus 3 times of Cl minus. So in this case what you can observe is there is 3 plus charge, or the oxidation state, or you could say the valency of this metal or this element is basically 3 plus. So we know the formula of equivalent weight as Z, which is nothing but the equivalent weight, is equals to molecular weight divided by valency. So in this case the molecular weight is to be estimated, but we know what would be the valency of AlCl3, the valency of the aluminum present in AlCl3. And recently we have calculated or we have estimated the value of the equivalent weight of the aluminum, which was found to be 9. And therefore, the valency, which is found to be 3, will give us the molecular weight as 9 into 3, which is 27 moles gram per mole. So this is the molecular weight of aluminum that has been determined by us. It was so simple. So thank you friends for watching this video. I hope you have got an idea that how to calculate the molar mass of a particular solution by using the equivalent weight and by using the formula of Faraday's first law. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.